Alright, on to question number 55. And it has a graph that looks like this. Standard XY coordinates. Draw this actually a little lower. And it has this line that goes through the point 0, 0. And then it has this line that crosses, the vertical line that crosses through the point 3. Well, this is a vertical line. Might not look like it, but it is. Okay, and then it says this point is 3 comma negative 6. So this is 1, 2, 3, 4, 5, 6. And it has this shaded. I'm doing a different color like this. This is shaded. All of this. And it says, which of the following systems of inequalities is represented by the standard region of the graph, or by the shaded region of the graph below? So it basically wants us to use the inequalities below to match up to see which one is graphed. So we can see that this right here, this line, is equal to x, is the line x equals 3, right? Because for all values on this line, x will be equal to 3. And this crosses through the point 0, 0. And we can see that at this point, it's gone over 3 and down 6. So for every 1 it goes over, it goes down 2. So the slope of this line, the slope in y equals mx plus b form, is negative 2x. And the y-intercept is 0, so plus 0, but we don't have to write that. So these are the two equations we're working with, and it wants to know what, with inequalities, if we turn these into inequalities, which ones will be matched here in this graph. So, is the shaded region to the left or to the right of this x equals 3? Well, it's to the right, right? So that means x will be greater than 3. Well, greater than or equal to 3 because it touches, and this is a filled in circle. And is y greater than or less than? Is the shaded, or I should say, is the shaded region to the right or to the left of this line? Is to the right, so it's greater than. Is the shaded region below or above? Well, it's below, so we have less than or equal to negative 2x. And now the only question is this, so these are our two inequalities, and are these connected with an and or an or? So is it y is less than or equal to negative 2x and x is greater than or equal to 3, or y is less than or equal to negative 2x, or x is greater than or equal to 3? Well, if it was or, that means all the values of x that were greater than or equal to 3 would be filled in. So we'd have all this area filled in. Anything to the right of the bar of x would be filled in. And anything less than y equals negative 2x would also be filled in. So we'd have all this extra stuff filled in, including this stuff. But we want just this part right in here. Just this. So we want when both of these conditions are true, and when we want both to be true, we use and. So that's our answer, choice A. And we'll go on to question 56. Just refill this in. And we'll go with this salmon color. Question 56 says, if f of x is equal to x squared, minus 2, then f of x, that's pretty bad, f of x plus h is equal to what? F of x plus h is equal to what? Okay, so if you're not familiar with this f of x notation, it's not that difficult. It's basically saying you can replace f of x with y. Y is equal to x squared minus 2. But f of x is a specific way, or a way of telling the specific number you're placing into the equation. So whatever term is inside the brackets is the term you'll be placing into the variable. So in this case, we have f of x. The x is in the brackets, so we placed x into the variable, which is why this equation is still in x form. So say we had f of 2, then we would place 2, we would substitute 2 into the x spot, which would have 2 squared minus 2, which would be equal to 2. But it wants to know what happens when we plug x plus h into that spot. When we substitute that into this equation for x, we would have x plus h squared minus 2, right? Because we just substituted the part that was in the brackets for the variable, and we're left with this. So now we can just FOIL, so x plus h times x plus h, because we're squaring this. So we can FOIL, so, well, we have minus 2 as well. So x squared plus xh, because we do the firsts, the outsides, the inners, so hx plus the last ones, h squared. And x times h is the same thing as h times x. You switch them, so x squared plus 2 xh, because we have 2 of these, plus h squared, and minus 2, and minus 2. And that is the answer. So we'll go on to question number 57. And 57, so let's just clear this really quickly. 57. Alright, so it says, which of the following is the graph in the standard xy coordinate plane of y is equal to 2x squared plus x divided by x? And then each choice has a graph that you have to match this up with. Okay, so just from this equation, well, starting off, if I was on the actual test, I would just put this in my graphing calculator and you could match up which line matched where. But just so you know the intuition behind it, we can figure out all the information we can just from this equation. So we can see that when we plug in x equals 0, it'll make this term or this quantity undefined because we'll be dividing by 0. But to tell if it'll be a hole in the graph or a vertical asymptote, to tell if, say here's the line, or say it's like this or parabola or whatever, when there's a discontinuity, when the denominator is 0, then there'll either be a hole in the graph, so there'll be a part that's just missing, it'll look like this, but the graph will just keep continuing on, or there will be a vertical asymptote, where say this is the coordinate plane, then the graph will say go all the way up, and it'll keep getting closer to this one line, but it'll never be able to touch it because that's the asymptote. And then it might come down from the bottom from negative infinity. It will get really close, but it'll never touch it because that's the asymptote. To figure out whether it's a hole or an asymptote, we could factor out this x, and depending on whether we can still plug in the variable will tell us. So when we factor out the x, we're left with y equals 2x plus x. And when I mean factor out the x, I mean just divide this term by x. Or excuse me, that's not plus x, that's plus 1. So now when we plug in 0, we get 1. So when x equals 0, there's a hole at y equals 1 because we can still plug in the variable, which means there's a hole. If we couldn't plug in a variable, that means then there's a vertical asymptote. So at the point 0, 1, there is a hole. That means there's something that looks like this, where the graph goes, stops, and then keeps going as it was going. So what else can we tell from this? We can tell that when we factor out that x, make this a simpler equation, that this is just a line with a slope of 2, right? Y equals mx plus b is the slope, or the equation for a line. So we know that this is a line with a hole at 0, 1, a slope of 2, and a y-intercept of 1. So right when this line crosses the y-axis, this is what the graph should look like. Right when this line crosses the y-axis at 1, there's going to be a hole. It'll skip right over it. There won't be anything in this area. There's no line to connect it. Then it'll just keep going on straight. So now if we look at the choices it gives us, we can see that choice A is the only graph that matches up with this. All the other ones, they have holes at the wrong spot, their y-intercepts are off, or they're not even a line. So I'll see you in the next video.